Hi friends, in this video we will discuss about CPU scheduling algorithms, preemptive and non-preemptive scheduling, and first come first serve scheduling. A typical process execution involves both input-output time and CPU time. CPU scheduling is done to maximize CPU utilization. We want CPU to keep executing some process. We don't want it to sit idle when a process is busy with input-output request. We want CPU scheduler to select the next process based on some CPU scheduling algorithm from the ready queue and allocates the CPU to it. In preemptive scheduling, the CPU is allocated to the processes for the limited time, and executing process can be interrupted in the middle of execution when higher priority process comes in. Examples of preemptive scheduling algorithm are round robin, shortest remaining time first, and preemptive priority scheduling. Under non-preemptive scheduling, once the CPU has been allocated to a process, the process keeps the CPU until it releases the CPU either by terminating or by requesting input-output. Examples of non-preemptive scheduling algorithms are first come first serve, non-preemptive SJF shortest job first, non-preemptive priority scheduling. Fcfs is the most simple CPU scheduling algorithm. With this scheme, the process that requests the CPU first is allocated the CPU first. Let's try to understand Fcfs scheduling with the help of an example. We will calculate average waiting time and average turnaround time. Waiting time of a process is the time spent by it waiting in the ready queue, and turnaround time is the time interval from the time of submission of a process to the time of the completion of the process. Let's assume all processes arrived at time 0 in the order P1, P2, P3, P4, P5 in the ready queue, and their CPU burst time is given. Now let's draw the Gantt chart. P1 is selected first for execution by CPU as it is arrived first. It will be executed by CPU for 10 milliseconds, so its turnaround time is 10 milliseconds and waiting time is 0 second. Then P2 is picked next for execution. Its turnaround time is 11 seconds and waiting time is 10 milliseconds. Then P3 is picked for execution by CPU. Its turnaround time is 13 milliseconds and waiting time is 11 milliseconds. Similarly, waiting time for P4 and P5 is calculated. Finally, we would calculate average waiting and turnaround time for these 5 processes. Fcfs algorithm is simple to implement, however, it have some drawbacks. Its average time is quite high as compared to other scheduling algorithms like SJF and round robin. Other disadvantage is convoy effect. All input-output bound processes end up waiting in the ready queue until CPU bound process is done. Now let's look at the Python implementation of Fcfs. Here is the output for the example we have discussed in this video. That's all for now. Thank you guys for watching this video. If you like this tutorial, don't forget to share it with your friends and subscribe to my channel. Inshallah, I will be making similar educational videos in future. Bye.